of the day, let's the topic you know very well. We're going to teach the electrochemical cell, and next we're going to see how electrochemical cell is different from electrolytic cell. See, Vichi, the happy point is we have studied electrochemical cell in very detailed manner, and other than that, we have another cell that is known to be electrolytic cell. But the best thing is we do not have electrolytic cell working in our syllabus. Okay, so we do not go through deep down in electrolytic cell, how is it working, how is its diagram, and many more things. But the point is 90% of the board exams of 12th class, we have seen the difference between electrochemical and electrolytic cell in 2 to 3 marks. Okay, so the point I wanted to say, let me start what is the difference between electrochemical and electrolytic cell. Okay, now the point here is we have already seen that electrochemical cell is defined as that we need our chemical energy. In electrochemical cell, we need our chemical energy to convert into electrical energy. है ना? For example, we have taken zinc and copper 2 positive. These were the redox reaction which was taking place. Half of the cell was taking with oxidation, whereas half of that was taking with reduction. है ना? But electrolytic cell is totally opposite to this. It defines that in this cell, or we can say it is the device in which electrical energy is supplied, in which electrical energy is supplied or given to bring chemical reaction. To bring chemical reaction. I hope I'm clear with the topic. It's totally opposite. In electrochemical cell, we were taking a cell in which chemical reaction is to be carried out, and that electrical energy we're using in many devices like motor, induction motor, or any kind of batteries. But electrolytic cell is totally opposite. It's the device in which we need to bring our chemical reaction. It has also reduction and as well as oxidation. It also has 2 half cells. But the point here is, in this case, we need electrical energy so that our chemical energy can be proceeded. Okay. Now the point is electrochemical cell. We have given it very name like as voltaic cell, or there was another name. I'm not getting that name right now. But electrolytic cell is defined as Daniell cell. And I hope in 11th class you have studied a little bit about Daniell cell in redox reaction chapter number 8. You have seen that there was a construction, there was a little bit working of Daniell cell. But Daniell cell was not so much important in our daily lives, so it was kind of rejected. We most of the time use this type of cell known as electrochemicals. Okay, so we have done what is electrochemical cell and what is electrolytic cell. Most importantly, salt bridge is required in electrochemical cell, but there is no salt bridge required. Okay, that is another difference. Now let me know, if salt bridge is required, what was the basic work of salt bridge? Salt bridge का main काम था कि उसे electrical neutrality provide करानी है, as well as he wants to connect 2 different electrodes. है ना? He wants to connect 2 different cells, half cell, so that ions or electron can easily move without mixing of the solution. That means if there is no salt bridge required in electrolytic cell, that means only a single beaker completes the reaction. Whereas we have 2 different beakers in which 2 half cells were present over there. है ना? There were half cell of reduction, there were half cell of oxidation, but in electrolytic cell only a single beaker we need, and there are oxidation as well as reduction, but there is no kind of salt bridge required. Okay, and lastly we would say electrochemical cell has provided us lone method, that is oxidation is taking place at anode, and anode is known to be negative, that we have seen A and N, that if my electrode is negative over there, we can say this is known to be anode, है ना? But if I'm talking about, as well as reduction at cathode. Okay. Now the point here is electrolytic cell is totally opposite to it. So it wants to say that negative electrode is known to be cathode. Yes, reduction is taking place over there. But the point is here the negative electrode represents, here the negative electrode is given the name of anode, whereas in electrolytic cell, negative electrode is taken as cathode. Am I clear? So in short, I want to say that electrochemical cell and electrolytic cell, they are totally opposite to each other. The very basic definition describes the differentiation between the two. He says that we need chemical energy, and that chemical energy we would use to make electrical energy. Hai cell is present over there, but we are using electrical energy to bring a chemical reaction. One more thing I want to describe here. Here was the redox reaction was spontaneous. What is spontaneous? Anyone knows what is the meaning of spontaneous? I hope you have studied this spontaneous word in chapter number 8 of 11th class redox reaction. Spontaneous means the reaction which is taking place automatically. That means we do not need to provide it any kind of heat, any kind of sunlight, any kind of energy. कि हाँ मुझे अपने reaction को start कराना है, so I need some energy over there. The reaction is starting automatically, it's proceeding through itself. Whereas in electrolytic cell, there is non-spontaneous redox reaction. And if non-spontaneous redox reaction is over there, that means quite obviously electrical energy is needed. Electrical energy is needed. तभी जाके हमारी redox reaction complete हो. Okay, so this was my electrochemical cell and this is my electrolytic cell. I hope you have got the idea what's the difference between the two. Very important question, bache, for the board exam point of view. And for competitive, it's not so important because electrolytic cell is not so much used. Okay, but you must remember that there are almost 5 to 6 differences which comes from 2 to 3 marks question. Okay, so this was it I wanted to explain. Now let's move with our next topic, that is main important topic of our class, that is electrode potential. What is electrode potential? Why do we need to study that? Let's see. Electrode potential was used when we have done our electrochemical cell. See बच्चे, अभी तक हमने electrochemical cell में we have seen its construction, we have seen its working, that yes, there is oxidation taking place, there is reduction taking place, है ना? We have seen both the points, but the point is what's happening when the chemical cell is converting into electrical energy. That means we have studied only 70 to 80% working of our electrochemical cell. The remaining portion is how electrical energy is produced and in which way our electrical energy is noted down. That means our electrical energy which has been we can say obtained from electrochemical cell, that is obtained, that is observed in the terms of electrode potential, and later we would see not on electrode potential, in fact EMF, electromotive force, but that's totally different topic. I just want to give you idea. Okay, so let's see what is electrode potential. See bache, whenever we have studied in our electrochemical cell, in our redox reaction, what we have seen that most of the cases there is oxidation, like metal is releasing electron from it and it's getting shrinking. This we have seen that was shrinking. we have seen that there is reduction taking place. That means electrons are getting deposited over it. It was releasing electron, but it is gaining the electron. And after gaining the electrons, the more negative ions start getting accumulated to each other. Right? So the mass would be increasing. So these were two basic concepts we have studied in our cell. So I just want to say electrode potential is the tendency of a half cell to gain or lose electron. I would repeat it again. If we have our metal with its own ion solution, then it has the tendency to lose or gain electron. That is known to be electrode potential. Am I clear? You have studied, बच्चे, that half cell हम उसे बोलते हैं when we have our metal surrounded by its own ions. है ना पुत्र जी? You have studied that in our last class. For example, if I'm talking by my zinc metal and this is surrounded by zinc sulfate solution, that means zinc metal is surrounded by zinc 2 positive ion. Metal is surrounded by its own ion. Then only it is known to be half cell. If we are taking zinc metal and copper sulfate, that's not a half cell. So in this case, it has tendency to lose the electron. That is known to be electrode potential. That is known to be electrode potential. Potential का meaning क्या होता है? Capacity, power. So it has the power, it has the tendency to lose the electron. Same as it is redox has the tendency to gain the electron. So these are known to be electrode potential. Okay. Now one more thing, I have told you that electrode potential are based on totally oxidation and reduction. For example, if I have taken the example of zinc and I have taken the example of copper, zinc is losing electrons, so oxidation is taking place. So I would like to define that electrode potential is electrode potential is named as oxidation electrode potential if oxidation is taking place at the electrode. So it is known to be oxidation electrode potential because oxidation is taking place at that particular electrode. Am I clear? Same as it is if I'm talking about my reduction, like as copper, reduction electrode potential because reduction is taking place over there. Okay, I hope I'm clear with the topic. What is electrode potential and what are its two different types? Okay, now let's move to our next topic, how electrode potential is determined. One more thing I want to say, electrode potential is defined as E. Okay, and I have told you that it has two different types. So E oxidation, E reduction. Okay, or we can say E anode, E cathode, depending upon which is taking place over. Okay, so it is denoted as E oxidation as well as E reduction. Okay, now we have observed very well what is electrode potential, but the point is how can we calculate our E oxidation and E reduction? How can we calculate our oxidation electrode potential or reduction electrode potential? Let's see, that's our next topic. Okay, one more thing I want to ask you, bache, is there any kind of doubt in the definition of electrode potential? Or is there any kind of doubt what are the difference between oxidation electrode potential, reduction electrode potential? Please let me know. If you can unmute, just say 1 or 2 students. If not, then please let me know in the chat box if there is any kind of doubt or not. Is it clear or not? Yes, is there any kind of doubt? No doubt. Very well done. No. Okay, bache. So I just wanted to see that there is no doubt in this topic. So let's move to our next topic. That is super important. No doubt, Ritu. Okay, good. All right. See, students, I have told you that we have two types of electrode potential, oxidation and reduction. है ना? And I have also told you that they're denoted by E oxidation and E reduction. Now the point is, these are my redox reaction, है ना? These are my redox reaction, and redox reaction is a reaction which is comparable reaction. यानी मैं ये बोलना चाह रही हूँ कि अगर मेरे पास रिडक्शन हो रही है तो ऑक्सीडेशन मैं उसको बोलूंगी जो उससे अपोजिट हो, है ना? So I want to say that this reaction is comparable reaction. This reaction is taken by a reference. Okay. Now, same as it is, if I want to calculate the E oxidation or the E reduction, I cannot calculate for a half cell. Suppose I'm given zinc with zinc sulfate, and I'm asked that please let me know what is the E oxidation. I cannot tell. This is not a way. I cannot describe the oxidation electrode potential, because oxidation electrode potential is a reference quantity. It should be referred, it should have a particular standard electrode which gives us appropriate value about it, है ना? So the next topic of today's discussion is reference electrode. I'm defining it again. To calculate the standard oxidation potential or to calculate the oxidation potential or the reduction potential of a half cell, we need a reference, we need a comparison, and that's why we have taken a reference or standard electrode. We have taken a standard, a reference electrode. Okay, so we would compare our zinc with some reference electrode. The value of this reference electrode is constant, and we would see if zinc is releasing electron, so it has oxidation electrode and it has something when. Okay, now let's see what is a reference electrode and what's its working. Okay, now the point here is, see, we have so many elements, but every one of them is very reactive and very different physical chemical properties which keep on changing. So for a reference electrode, we need something which has very constant property and which do not interfere in my reaction also. Okay, क्योंकि मुझे तो सिर्फ अपना काम निकालना है, मुझे तो सिर्फ अपना ऑक्सीडेशन पोटेंशियल निकालना है, and that's it. Then I would go on with my next case. That means अगर मुझे उसका E oxidation पता चल गया, I would go to calculate the electrical energy, ना? So to take a reference electrode or standard electrode, we take hydrogen. This is also known as hydrogen cell. Okay, now let's see a simple working of hydrogen cell. I have a diagram. One more thing, it would be better if it would about electrode overthink. Okay, now let's see. See, the point here is, मेरा जो रीजन है, मेरा जो इलेक्ट्रोड है, मैंने जो हाफ शेल की डेफिनेशन दी है, वो हमें ये बोलता है कि we need metal and we need its ions. That means metal is surrounded by same ions. So let's say we are taking a beaker, and in that particular beaker we have 1 molar HCl solution. That means we have fixed the quantity, we have fixed the concentration of HCl solution. That is 1 mole. हमारा प्रॉब्लम जो है वो आधा सॉल्व हुआ है कि हमने HCl ले लिया क्योंकि हमें हाइड्रोजन इलेक्ट्रोड चाहिए. But the point is, what do we need as a metal? Is hydrogen a metal? No, definitely not. It's a non-metal, it's a gas. Then what can we do? We would take a glass jar, and in this glass jar there is opening so that solution is getting into it, and we have taken a platinum metal. What we have taken? We have taken a platinum metal. Why do we need platinum metal? Because platinum is my non-reactive metal, or we can say it is the least reactive metal among all the metals. So we have taken platinum, and for making hydrogen, we have filled up with H2 gas. We have filled up with H2 gas. That means this glass jar is completely filled up with hydrogen gas with platinum metal with 1 molar HCl solution. Okay, so in this case, we would get that yes, my standard electrode potential has been taken place, है ना? So this is known to be my standard electrode, reference electrode, or hydrogen electrode. Or yes, this metal is connected with any kind of, I would say, battery or something. Like this is connected with some force, some charge. Okay. Now I want to say this electrode is my inert electrode. That means it is least reactive. It is not reacting with my reaction. But the point is, since it is a standard electrode, since it is a reference electrode, and we have seen that there are some oxidation electrode potential and some reduction electrode potential. That means I can say that hydrogen electrode is behaving both as oxidation as well as reduction. Like H2 is releasing 2H positive plus 2 electron. This is oxidation. Same as well, 2 hydrogen is taking electron. So I just wanted to say, bache, hydrogen is something which has to behave as a reference electrode, and it also taking place as oxidation as well as reduction, because it is a reference, because it is taken as a reference electrode. So some electrodes are oxidation and some electrodes are at reduction. Okay, so it should have the property of both type of. And one more thing, its electrode potential is taken as 0.00, or we would define it E naught, where E naught denotes the standard electrode potential, है ना? Because 0 को उसके साथ compare करना is very easy. All right. So in tomorrow's class, we would see how this standard electrode is calculating the oxidation electrode of zinc and the reduction electrode of copper. And then we would go with the topic EMF, electromotive force. Okay. So this was the topic I wanted to explain. Now, please let me know if there is any kind of doubt or query in this topic. Yes, anyone? Please let me know. Raise your hand.